Welcome to class 9 mathematics. The topic is lines and angles. Yesterday's class we have discussed and we have done the problems on lines, line segments and different types of angles. Today, we will discuss about the transversal. What is a transversal? So here a line segment which intersect the two lines at two distinct places is called a line, is called a transversal. So here I am taking the two lines. This is M and L, N. These are the two lines. M and N are the two lines, and line L is intersecting M and N at two different places, that is P and Q. A line segment which intersects the two lines at two distinct places is called a transversal. And if this line is intersecting the two lines at distinct places, then 8 angles are formed. They are 1, 2, 3, 4, 5, 6, 7, 8. So here, first we'll deal with angle 1 and angle 3 are vertically opposite angles, and angle 2 and 4 are vertically opposite angles. So here 5 and 7 are vertically opposite and 6 and 8 are vertically opposite. So children, here L is a transversal and M and N are two lines. When L intersect M and N at P and Q points respectively, the four angles are formed at P and Q respectively, namely 1, 2, 3, 4, 5, 6, 7, 8. Totally 8 angles are formed. So here angle 1 and angle 2, comma, angle 8 and angle 7, or angle 7 and angle 8 are exterior angles. And the next is angle 3 and angle 4 and angle 5 and angle 6 are interior angles. Now here these angles we will classify in the following ways. The first one is corresponding angles. So here 1 is correspondent to 5 because here it is an exterior angle, 1 is an exterior angle and 5 is an interior angle here. So angle 5 and angle 1, or angle 1 and angle 5 are corresponding angles, and next is angle 2 and angle 6. In the same way angle 4 and angle 8 and angle 3 and angle 7. These are corresponding angles. The next is alternate interior angles. So alternate means that means side, one is going to be left side and one is going to be right side here. Alternate interior angles, I said interior angles, the angles that are present in between the two lines, that is M and N, then these are called interior angles. And alternate means one is going to be right side and one is going to be left side of the transversal. So here angle 4 and angle 6, comma, angle 3 and angle 5 are alternate interior angles. The next is alternate exterior angles. So angle 1 and angle 7. The next is angle 2 and angle 8 are alternate exterior angles. Exterior means outside of the two lines M and N, and they should be one angle should be right side and one angle should be left side of the transversal. So here when I am adding the sum of two interior angles on the same side of the transversal, that is angle 4 and angle 5, this value is going to be equal to 180, and also angle 5 and angle 6 value is also equal to 180. So the next is relationship between parallel lines and a transversal. What is the relationship between parallel lines and transversal? So here I am taking two parallel lines. M and N are two parallel lines and L is a transversal. So again, if L is a transversal and it is meeting M and N at two distinct places, that is P and Q, then totally 8 angles are formed. Angle 1, 2, 3, 4, 5, 6, 7, 8. So based on these 8 angles, we are going to find the relationship. So if the transversal intersect two parallel lines, then each pair of corresponding angles are equal. The first condition is if the transversal intersect two parallel lines, then each pair of corresponding angles are equal. So clearly we know, we studied about the corresponding angles, that is angle 1 is equal to angle 5. Angle 1 is equal to angle 5, comma, angle 2 is equal to angle 6, comma, angle 4 is equal to angle 8, comma, angle 3 is equal to angle 7. These are the corresponding angles and they are going to be equal. We'll take one example and we'll check it. The next is if a transversal intersect two parallel lines, then alternate interior angles are equal. Alternate interior angles are equal. Now I am taking alternate interior angles are equal. What are alternate interior angles here? Angle 4 is equal to angle 6, comma, angle 3 is equal to angle 5. So these are the alternate interior angles. Next is if the transverse intersects two lines and alternate interior angles are equal, then they are called parallel lines. If alternate interior angles are equal, then automatically these two lines are going to be parallel. Or in the same way, if corresponding angles are equal, then M and N are parallel lines. In the same way, next is alternate exterior angles are also equal. Then what are the alternate exterior angles? Angle 1 is equal to angle 7, comma, angle 2 is equal to angle 8. These are alternate exterior angles. So I am going to take one example and we'll check it whether they are equal or not. So same figure I am taking. So one angle is given, that is M and N are two parallel lines and L is a transversal, and one angle is given, that is angle 1 is equal to 40 degrees I am taking. So angle 1 is equal to 40 degrees, then clearly we know these two are intersecting lines. Okay, L is intersecting at two distinct points. Then first condition is angle 1 is equal to 40 degrees. Then what about angle 1 is equal to angle 3? Because they are vertically opposite angles. Then angle 3 is equal to 40 degrees. So this is also 40 and it is also 40. So now it is a linear pair. Angle 4, angle 1 plus angle 2 is equal to 180 degrees because it is a linear pair. Now angle 1 is 40 degrees plus angle 2 is equal to 180. Then what about angle 2? Angle 2 is equal to 180 minus 40. That's equal to 140 degrees. Now angle 2 is 140 degrees. Now when I am adding this, I am going to get 180. Hence it is a straight line. If it is 140, then automatically angle 2 is equal to angle 4. These are vertically opposite angles. Now therefore angle 4 is equal to 140. Okay. Now it is 40, 140. Now angle 1 and angle 5 are corresponding angles. Angle 1 is equal to angle 5. What are these? These are called corresponding angles. Then what about angle 1? Angle 1 is equal to 40 degrees. So therefore angle 5 is equal to 40. This is also 40. Now next is angle 4 and angle 2, or these are alternate angles. Now angle 4 is equal to angle 6. These are alternate interior angles. Angle 4 is 140. Then what about angle 6? Angle 6 is equal to 140 degrees. Now it is 140 degrees. Okay. Now, then what about this value? Angle 4, angle 1 and angle 1 is equal to angle 7, because these are alternate exterior angles. So therefore angle 7 is equal to 40 degrees, or directly we can say that these are vertically opposite angles. So in the same way, angle 2 is equal to angle 8, alternate exterior angles. Therefore angle 8 is equal to 140 degrees. If these angles, that means alternate exterior angles are equal, corresponding angles are equal, or alternate interior angles are equal, then M and N are two parallel lines and L is a transversal. So based on this, we will solve some problems. Children, we'll solve one theorem. If two lines intersect each other, then vertically opposite angles are equal. Now I am taking the two lines here, AB and CD are two lines which are intersecting at a point O. Now I have to prove that angle AOD is equal to angle BOC and angle AOC is equal to angle BOD. That means when two lines intersect each other, then vertically opposite angles are equal. To do this, so here is the proof here. So what proof? It is given that in the proof first is given. What is given? A and B are, AB and CD are two lines intersecting at O. Now I have to prove, what I have to prove, that is required to prove, that is angle AOC is equal to angle BOD and angle AOD is equal to angle BOC. That means here these two angles are equal and these two angles are equal. So now to prove this, I'm doing the proof. So here ray OA stands on CD and ray OB stands on same CD. Sorry, ray OB, or I am taking OD, stands on AB. Now see here angle AOC, therefore angle AOC plus angle AOD is equal to 180 degrees, because angle A, it is a straight line here, it is a linear pair. OA stands on CD, then automatically, so this is a linear pair here. These two are the angles, then angle AOC plus angle AOD is equal to 180 degrees. This is the first equation. And the same way OD, and this is also a linear pair. Now here angle AOD plus angle BOD is equal to 180 degrees. It is a linear pair. Now from 1 and 2, from equations 1 and 2, RHS are equal, then automatically LHS will be equal. Then angle AOC plus angle AOD is equal to angle AOD plus angle BOD. AOD cancel. The remaining is angle AOC is equal to angle BOD. AOC is equal to angle BOD. Similarly, we can prove angle BOC is equal to angle AOD. So hence proved that when two lines intersect each other, then their vertically opposite angles are equal. Children, next we'll start the exercise number 2. In the given figure, the values of x and y, and then show that AB is parallel to CD. So here this is the figure. AB and CD are two parallel lines, and EF is a transversal. Now the angle is given 50 degrees, one angle. Next I need to find the x. So here y, and next one more angle is given 130 degrees. Now I have to prove that these two, based on this data, I have to prove that AB is parallel to CD. Now here I am solving. So this intersecting point, this is G, and this intersecting point is H. So here clearly given that angle, so first one solution I am doing, angle AGE is equal to 50 degrees, and one more is angle CHF is equal to 130. So I have to find the value of x and y, and also have to prove that AB is parallel to CD. Now here angle AGH plus angle AGH plus angle AGH plus angle AGE is equal to 180 degrees because it is a linear pair. This value and this is a straight line here. AGH and AGE is equal to 180. Then AGH value is x plus, and AG is 50. That's equal to 180. Now x is equal to 180 degrees minus 50 degrees. That's equal to 130 degrees. X value I got 130 degrees. So in the same way, angle AGH is equal to angle GHD, because AGH is equal to angle GHD, because these are alternate interior angles. Alternate interior angles. Now it is 130 degrees. So therefore y is equal to 130 degrees. The next question is, that is second one. In the figure, AB is parallel to CD. This is the figure. AB is parallel to CD. That means AB and CD are parallel lines, and CD is parallel to EF. That means automatically, so these three lines are parallel lines. And one more is given. This is a transversal. So here I need to find the value of x, y, and z. And the condition is given y is to z is equal to 3 is to 7, and I need to find the value of x. Y is to z is given 3 is to 7. So here clearly AB is parallel to CD and CD is parallel to EF. Then automatically AB is parallel to EF also. Now I am proving this. Clearly given AB is parallel to CD and CD is parallel to EF. Therefore AB is parallel to EF, and I am taking GH is a transversal. GH is a transversal. So therefore now x is to z. GH is a transversal, and one more condition is given. Y is to z is equal to 3 is to 7. These all are given. Now clearly I am taking AB is parallel to EF, then GH is a transversal. I'm excluding this CD and I'm taking AB and EF are two parallel lines. Then automatically, so angle A, then X and Z are alternate angles. So therefore, X is equal to Z. These are alternate angles. And for us it is given y is to x is equal to 3 is to 7. Let the common ratio be, so here already x terms are there, so I am taking p. Then x is equal to 7p, comma y is equal to 3p, comma z is equal to 7p, because z and y are same. So therefore x plus y is equal to 180, because angles on the same side of transversal is 180. Now x value is 7p plus 3p is equal to 180. 10p is equal to 180. P is equal to 180 by 10. 0, 0 cancel. That's equal to p value is 18 degrees. So here p value I got, that is p equal to 18 degrees. Now x is equal to 7p, that's equal to 7 into 18 is equal to 126 degrees. Now y is equal to 3p, that is 3 into 18 is equal to 54 degrees, and z is equal to 7p, because x and z are equally up. That's equal to 7 into 18 is equal to 126 degrees. So thank you children, we will discuss some more problems in the next class.